both Peiheng and me, we are a part of this ASU Translation AI Lab. Peiheng graduated from ASU a couple of years ago, but he's one of the leading engineer in the Norfolk Southern, one of the Class 1 railway companies, who is also part of our INFORMS RAS committee. So let me begin the discussion on the topic of open source ecosystem for intermodal transportation. We will talk about challenges and opportunities. So we have a total of the 4 different small sessions to open up with the open specification. Why do we need to build a community? And what are existing tools we have in terms of intermodal modeling? And then I would like to ask Peiheng to go over the theory and the implementation behind of a recent open source TransOMS as one example to show how we can build such open source tools and ecosystem together. Many years ago, when I started working with Federal Highway, we do see a number of challenges. We have many different data sources or different tools. For example, highway capacity manual, land use, traffic assignment. We do want to see an integrated vision of all the different modules or the tools, but we only have ad hoc connection if we do not have a standard. In the last few years, as I try to introduce to the audience very soon, we are start building mainly based on the driving mode, GMNS specification, so that we can connect different modules together. This is the part of the long-term vision for system-wide coupling of the different subsystems. We also see many challenges, in particular, how these AlphaGo or ChatGPT have a huge potential or impact to our industry. We have been talking about different CPUs or deep learning tools. We have been talking about how the other computationally intensive area can utilize all their ecosystem to use different layers of open source systems to perform deep learning or reinforcement learning. What we can do, can we try to use 1 million cores, CPU cores, to solve an integer program? Can we try to use those emerging computational power to address our intermodal routing scheduling problem? And how we can integrate all the different operational planning together. So in this talk, I try to showcase a number of initiatives we have in terms of building the open source driving only specification at the current initial stage. And then we do want to highlight we are in the process of provide the open specification or the open data available for rail, water, road. This is a multi-resolution network. This is about 20 billion nodes, thanks to many communities' effort. And then we are talking about why we still need to go one more step further to build a multi-resolution in terms of regional, macroscopic, mesoscopic. So the definition of the resolution can be quite flexible, but we just try to show all the different ways for us to work together. It's easy to say open specification, but it's difficult to just try to have one specification fits all the different modes. So at least a number of challenges based on our initial understanding. Different mode might need what is specific information. For example, driving mode, you have one-way or two-way driving direction. But for single track, double track, different number of tracks is one of the very critical element for our railway operation. When we try to satisfy the real world requirement, we need to understand we have many different ownership of the tracks, such as 7 or 6 Class 1 companies in the United States. And the data structure is challenging. We cannot just simply use a database to represent everything. We might need to use XML or tree-based structure to encode all the essential information. After we have the network in transportation, how we can use a GIS or use a particular open tool to modify the network. Unfortunately, at this stage, the network manipulation was not standardized. I mentioned the different data format. In the current GMNS specification, we are starting with CSV format for the easy of the use. But I think in the long run, we have to move to JSON, XML, SQLite database to be more inclusive and integrated. We do see we have been many great activities in automobile-oriented specification, but driving mode only is not going to solve the problem. We need to see bicycle, pedestrian, and more important in today's lecture, railway-related specification. And finally, we hope those cross-mode standard will help us to ensure the complete trip across different modes. So let me try to introduce the GMNS. This is the long name, difficult to pronounce once, but GMNS stands for General Modeling Network Specification. Great news here is when you try to type this keyword, you will always just get the GitHub right away. It's part of the Zephyr Foundation, a non-for-profit organization in the United States, and the specification at the current stage is managed also through a number of industry partners, and all the planning agencies, and the specification currently is provided in terms of the report by the Volpe Center GMNS team, Dr. Scott Smith and Ian. They are the two main persons in drafting all the specification. At the current stage, the specification has a version number of 0.9, very close to 1.0. In the very early beginning of the designing this interface or this specification, they do consider different resolution at link level, at the lane level, so that we can try to encode many different elements together. So I would like to just show this CSV file, node.csv, link.csv for researchers or academia researchers here and industry partners to look at how easy for you to generate one specification along this way. In this specification, we have a node ID, we have longitude or latitude, we have the different additional attributes such as activity, location, such as the type of the signal control in the driving case. For the link, we have form node ID, tool node ID, and we have the direction flag. And we also have the length typically coded in meter. And we have the speed limit, we have capacity. So one interesting question here is, as you can see, when we try to code a link in a railway network, we might say upstream node, downstream node, A node, B node, form node, tool node. So in this specification, we use form node ID, tool node ID to standardize the representation of a link. We can also add the geometry information as the WKT format or the geometry format. And then we have allowed use this very flexible field to code. Do we allow different type of driving, biking, bus, truck, or even HOV, HOV3+, high occupancy vehicle to use those different type of the facility. We also have many different location systems to indicate parent to children relationship so that we can add sidewalk, crosswalk, many different commodity consideration. As you know, GTFS, the General Transit Specification, which is quite popular in the public transportation domain. They can use this GTFS to share bus stop, timetable in a very visible way. So we do build the GMNS is mainly for the routable routing application as a bridge to the public accessible GTFS specification. So at the current stage, we do have a number of open source or open data source to provide driving and biking and railway, or maybe you can also just extend that to the different airport modes. So our student or former student, Dr. Jiawei Lu, has been produced this wonderful Python package OSM to GMNS to read OpenStreetMap data and then provide the corresponding standard network format in different modes. Some researchers might have this interesting question. How about the accuracy of this open community data? I would like to say in terms of class of the road, in terms of highway, freeway, or the different type of tracks, we have a very high percentage in terms of the correctness in the OSM database. And then if you go to number of lanes, if you go to very detailed signalized intersection, we still have some extra room for us to improve. But I would like to say with the community effort, once you build your model for this specification, and you can apply your model with enhanced data set, and you can apply your model to any city or any state very easily. I would like to just go very quickly to see how the multi-resolution is coded in a driving case. I think we need the community's effort to have more consensus to build this multi-track or to try to just specify railway station specification. So here, I look at a link in the driving mode. We try to consider different segments with a homogeneous number of lanes. And then we try to code the lane number from left turn -1 through 1, 2, 3. If I try to just highlight here, and then we have lane number 4 for the bike. We can also have the movement specific information such as left turn, through, right turn, and the different color here represent the different driving only, bike, pedestrian only, different mode as allowed use. I will not go to all the details in terms of the controller movement, signal timing, but you can see once we have a uniform network representation, we can attach many useful control information on top of this specification. Let me just try to categorize the different tools we can build along this community, along this specification. I would like to categorize here as A, in terms of the network, B, in terms of the demand. The demand here, we are talking about the driving mode or multimodal urban travel mode. In the future, we need to consider intercity demand or the different commodity of the demand in this railway application. Traffic control strategy in terms of the signal timing or maybe different blocking strategies we have at the different tracks. And the category D, I simply say simulation, but I think what I mean is optimization, simulation, machine learning can always just build on this category A, B, C for the better application. I also want to show just more than GMNS, the many specifications, at least based on my knowledge in the United States. In federal highway, there's a enterprise GIS in transportation for the state agency. So you can see the GMNS, as you can see here, is a small part, and the many different prototypes are provided to link all the different standards together. Both public sector and the private sectors, they try to build the digital twin. Allow me to say that all the digital twins require the specification as a firm foundation. So I will go very quickly on a few steps to show how we can download the data, convert the OSM data, and then try to generate the essential OD demand. And I would like to ask Dr. Peiheng Li to go over the most challenging part of the Path4GMNS and all the enterprise-grade optimization tools. So we can try to build an OpenStreetMap network easily. Just bear in mind here, we will not only talk about node and link. You can try to add all the activity locations, point of interest as a part of the network. You can have drivable network, bikeable network, walkable network across different modes. We can have multi-resolution network for the different modeling needs. And then by using that, you can try to ensure the consistency across different modes. On this cell-based microscopic network, we do digitize lane by lane, cell by cell. A cell typically is about 5 meters in length. And all these microscopic high-fidelity network can be automatically generated based on the macroscopic node link representation by using number of tracks, by using number of lanes, and then try to expand this intersection further. One of the leading example we have here is in this United States network. We do have a tool currently has been downloaded more than 50,000 times to generate the entire driving network with about 20 million nodes. And we can try to just take the further connection to RailNL, okay, which is also initiative to support the further development of open source railway specification. This is a part of the microscopic simulation. And how these data standard can be connected is always interesting for us to move forward. So I will just simply highlight the different level of the requirement. When we talk about high level blocking plan, line plan, and we need to use a regional or statewide network. When we talk about corridor level transportation scheduling timetable, dispatching, redispatching, we need to look at a meso level representation. If we talk about the train dynamics, signal control, speed profile, I think we also need to build a cell-based meter by meter representation in this regard. And I do see a number of challenges here to model the railway network, such as how do we model the railway station, how we try to ensure the consistency across different layers, and I list a number of leading researchers in this regard try to address the consistency across different layers. And we do have a tool of a OSM2 layer. At this current stage, we generate the different station, different layoff of the tracks, and this is a part of our ongoing process for us to provide a good specification to the community. But we need to connect our community from the different countries, from the different application domains, so that we can build a common interface or common database for such of the specification. And I just try to stop here, and I would like to ask Dr. Peiheng Li to open up his discussion on the different tools he has been working on. Peiheng, you can just let me to move to the next slide when you are ready. Go ahead.
Thank you for the introduction. And good morning and good evening, everyone, depending where you are. So I'm Peiheng. I'm with the Norfolk Southern Operations Research Group, one of the 7 Class 1 railroads in North America. So starting from the next slide, we are going to switch the gear and to focus more on the modeling ideas and implementation details behind some of the tools we have been working on in the past few years. So this is the roadmap for the ecosystem we have been working on. So Dr. Zhou spent some time on the OSM to GMNS, which is to generate the data format we need, or generate prepare the network for we to start. So this is serve as the great foundation to all the other applications. So along this line, we have different tools, being developed or in our horizon. So including capacity planning, simulation, optimizations, and scheduling routing tools. And our eventual goal is that to wrap them all together into a web-based application. So to give a user a fully integrated and interactive user experience. So today I'm going to focus on 2 of them. One's the Path4GMNS, the other is TransOMS. Can you go to the next slide, Dr. So here is the architecture of Path4GMNS. So Path4GMNS is an open source, cross-platform and lightweight and fast Python engine for networks encoded in GMNS. So we have been working on it in the past 2 years. It has 2 parts. So the first part is mainly the Python modules. So we have the static traffic assignment, and we have the simulation-based dynamic traffic assignment. And we also have provide the functionalities for accessibility and equity evaluation. And in addition to that, we offer a zoom and demand synthesize. So if you don't have any demand data, we can automatically generate it for you, so you can use the package without any dependency. So its core is a Path engine written in C++. The reason we have the C++ engine here is twofold. So first of all, we want to take advantage of the advantage of C++ to fully utilize the computation power provided by the hardware. The other is that many network flow problems can be decomposed into sub-problems as shortest path problems through proper transformation, which I will go through in the next few slides. So on the right-hand side is the DTA line, which is the status of code in traffic analysis. So it includes more than what Path4GMNS has been offered. So in addition to the static traffic assignment, they also have the queue-based dynamic traffic assignment, and also include origin destination demand estimation. So, and we remove the code bloating and some of the vendor specific implementations in the original DTA, and make it cross-platform and embed it into the Path4GMNS. So now you can use DTA Lite within Path4GMNS. So on the other hand is TransOMS. So the key difference is that it's purely written in modern C++. So with modern C++, we can actually write cleaner and faster applications compared to the classic C++. So this is an application towards transportation optimization, modeling, and simulation. So we have a lot of cutting-edge research from the research community, but unfortunately, we don't have many good quality open source projects. So with this initiative, we want to bring the cutting-edge researches and integrated the enterprise great implementation altogether into one place. Okay, so okay, sure. So with different resolution networks, and if we want to do the integrated modeling and optimizations, which is quite challenging because the problem size and the complexity are high. So a common way to resolve this issue is through decomposition, to decompose the original master problem into different subproblems. Typically, there are two types of decompositions. So you can either decompose the problem in horizontal and vertically. So you could have the hierarchical scheme, which are connected by the bounding, by the coupling or bounding constraints. The other way is that you could utilize the nest features, the nest structures of the problem itself, and decompose the problem into in the horizontal way. So you could lead to the parallelism, or you could do the distributed computing to fully utilize the computation power of the computer clusters. Can go to the next one. So column generation, you can think of as another decomposition, because this is basically another decomposition. But the core idea behind column generation is to avoid the full enumeration of all the possible columns or paths, because sometimes enumeration of them is not possible. And so based on depending how do you relax your master problem, you could have two different streams for the column generations. So either you relax the problem using linear programming, or you can relax it using Lagrangian relaxation. So that will have different forms of the present information. So represented as either simplex multiplayer or Lagrangian multiplayers. Okay, but after the so the problem here is a flow assignment problem. And here we will show that through the decomposition, we will transform the problem into two subproblems. One is column generation, the other is column updating, which embeds the reduced gradient and gradient projection. Okay. So for column generation, after the relaxation, the solution might not be feasible, because you may have the fractional solutions, or if you're using Lagrangian relaxation here, you could violating the partitioning constraint here. But basically, they're the same. A common strategy is to utilize the branch and bound procedures, to resolve the infeasible issues here. But on the other hand, these partitioning constraint violations from the from Lagrangian relaxation can be viewed as the symmetry issue of Lagrangian relaxation. So in other words, a lot of supply resources are computing for the same demand request. So you need to have a scheme, to fix the potential combinations. So a possible remedy here is to use ADMM, alternating direction multiplayer method of multiplayers. Please go to the next one. Next. One before. You're
yeah, so the control of the zone was not perfect. You had to just go forward. Okay, Peiheng, yeah, I think the control of the zone was in this presentation mode is not perfect.
So I think I skipped. Okay.
I can only just move forward, not backward.
Previous. Can go to previous. Previous, the second one. Yes. Just one more, and one more. One more.
Okay.
Okay. So the core part of the column generation is the routing. So which is with consideration of the present information, either from the simplex multipliers or Lagrange multipliers. Okay. And for the routing itself, the common routing engines we have are shortest path algorithm and dynamic programming, or more specifically forward dynamic programming. And we could also use some of the search methods like the DFS and BFS to do that. And column generation is very popular and useful modeling techniques. And in the past 2 years, we at Norfolk Southern, we have been working on a modeling and solution framework for the railroad routing problem or the train routing problem. So it is to generate the optimal train routing plans. So, and the core of this modeling and solution framework is column generation. And we have it fully developed now at this point of time. We gave a short presentation during last year INFORMS annual conference. So hopefully I will get some chance to present its modeling ideas and the numerical examples in the future. Okay, can go to the next one. So here we will focus on the shortest path algorithm as part of the routing engine. So there are a lot of shortest path algorithms, but the efficient ones are very limited. So the first one is the DAC implementation of the modified label cracking algorithm, and the other is the heap digestion algorithm rather than the original heap algorithm. You could think of the heap digestion algorithm as a special implementation of the modified label cracking algorithm. And the caveat of these two efficient implementations is that their efficiency is highly affected by the underlying data structure on how do you update the scanning eligible list. Okay. And go to the next one. So for the DAC implementation, it involves a heuristic because the modified label cracking algorithm doesn't impose a restriction of how you update the underlying data structure, the underlying data container. So with DAC implementation, it has a heuristic based on the status of the node, which has been scanned or not. So if the node was in DAC before, which means that we already scanned this node before, you can add it to the front. If the node is not present and was not there before, so this is a pure new code, new node, we can add it to the rear. So it is quite straightforward heuristic. Basically, you can use any data container supporting sequential access to store it, but it will lead to the performance difference. So a common one to do is using the vector or the list from Python. So, but be careful. So for the STL vector, it involves a constant. This constant rear instruction. This constant is you need to put a code there, so it is on average. Because each time if you insert the new elements to the end of the container, it may have the chance that the capacity has been exhausted. So you would have to allocate a new chunk of memory and copy all the existing elements and including this one. but on average it's constant. And for the removal and insertion, it is always linear time because it is.
Peiheng, I have to interrupt you, and I feel that we are running out of time. If you go to many details, I do receive one comment from the audience. What's the problem? What's actually the problem here? Is it practically helping stakeholders in real life problem, or is it theoretical computation by itself?
It is a both theoretical and practical problem in transportation. Okay, I think I already answered that question. I will go skip the question here. So the remedy is to use the stack, use the DAG, and go to the next one. But there's a hidden cost involved with the STL DAG. So, and the performance really depends on the implementation strategy and the platform. So here at least a summary over 3 different compilers on 3 different platforms. You can see that with the DAG implementation, the performance is even worse. Sometimes it's even worse than that using vector. Okay, so our remedy is to have a special DAG, so with no overhead on memory allocation, deallocation, and corbing. Okay, and we go to the next one. So for the heap digester algorithm, for the digester algorithm, its case is to identify the node with the minimum distance cost. So it involves a sorting. So you could go through do a linear search, find the one with minimum cost, or you could store all those nodes into a heap to utilize the built-in feature, sorting feature from the heap. And there are 2 representations. One is tree and the other is array. I think I'm going to skip the details here, but the takeaway here is that the common implementation is using array. And using array, the cause is that the pop operation is not logarithmic, it's rather linear. So I'll leave the details here. So with that, you cannot get the time bound, time down by design. So we are working on a minimum heap which guarantees the logarithmic time of operations. Okay, and go to the next one. A critical operations in this application is that to identify to check whether a newly identified column is existing or not. So there's 3 different strategies. So you could go through each element, do a side-by-side comparisons using linear search, and you could utilize some of the key and do a binary search if you store into a tree-based container, such as set or map. The other is that you can enable a constant check using the hash table. This is the most efficient way. And so this is the implementation from our applications. We combine distance and number of links. Okay. So as I mentioned before, we could do 2 types of decomposition. The first one is the vertical and the other is horizontal. So through the vertical decomposition, we transform the problem into 2 subproblems. One is the column generation, which is to generate the columns we need. The other is to do the column updating in terms of the flow shifting. And can go to the next one. So with the horizontal decomposition, we actually can enable a multiprocessing or parallelism, because I just use the column generation as a simple example. So you could divide the original data set into different original data set, and for each one of them, you're going to calculate the shortest path. It has no overlapping with the other data sets. So this is a pure parallel computing or multiprocessing. And you could, if the network is really large, you could distribute some of the computations over computer clusters. As Dr. mentioned before that, we start with the CSV as the data communication format. But the challenging part is that C++ doesn't have official support for CSV. So you could use some of the built-in functions to do the parsing, but it's a nightmare. And there are some the CSV parser on the market, but neither of them match our design goals. So this is a typical regular CSV parser. So which involves each line of parsing involves 4 times of copying and 2 linear searches. Can you go to the next one? So we want our parser as efficient as possible or landing faster. So we do the enhancement. So first of all, we consolidate the 2 linear search into 1. And then we remove the unnecessary copying with the more semantics introduced by the modern C++. And the other is that the original CSV file could be very large, and copying from the file to the system buffer could be very time consuming. And the remedy here is to use the memory mapping to avoid the I/O data movement, which enables the fast data retrieving. Okay, go to the next one. So here I list the time bounds of these four different parsers here. The first 2 are only using the standard facilities from C++, and the other 2 using the memory mapping. And okay. So the bottom line here is that that one is really fast, which can match the CSV parser from the Python package, which is written in C. Okay, and so we want to test the performance of our network, the applications. So our test network is the Chicago Regional Network. It's a big network, and the baseline is the DTA line, which is status quo. So at least the running time of each components here, including computing, I/O overall, and memory usage, and even the convergence of the accuracy of the computation itself. So as you can see here that this one, TransOMS, is able to outperform DTA line in every aspect, and using much less memory. So I want to emphasize here a little bit more on the I/O part. So this I/O includes both input and output. So basically, both DTA line and TransOMS can load the data in seconds. The dominant part on the outputting part. So I hope those figures are not misleading here. Move to the next one. So this is just a starting point. So to answer the question here, so this is a practical question for flow assignment or demand loading problems. So which is a common problem if you're doing the long-term planning or especially capacity planning. Okay, so this is just the starting point because we initiated this project 2 months ago. And along this line, we are going to add more, including the origin destination demand estimation, the simulation-based DTA, and recently we have been working on a queue-based volume delay function. With that, we could capture the queue dynamics without using the queuing model. Through simulation. So we're working on an analytical simulation as well, analytical DTA as well. The next one, as Dr. Zhou mentioned at the first beginning, we have a lot of emerging technology here. So one of them is the computational graph. And we could utilize as the nonlinear programming solver and to solve all those problems. And there are more. Can go to the next one. So here is the overall picture of the GMNS Plus. So the biggest obstacle or the barriers in the past is we don't have a common data specification. So with GMNS, we are removing this specification, and with that, we are hoping to to bring more integrated modeling and modeling frameworks. So instead, so with the different resolution network here, so on the macroscopic, we can do the capacity planning, and we could do the network design. And on the mesoscopic, we can do the trip planning. And down to the macroscopic network, we could do some of the mid and path plan in terms of the space-time trajectory. And they are all integrated through some of the bounding constraints, as we list on the right-hand side. Okay. Can go to the next one. So intermodal transportation is different with a single mode. It involves different transportation modes, involve railroad, public transportation, and trucking, the cargo ships, and on the other hand, we have a broad research community, including the practitioners from the industry, planners, engineers from different transportation agencies, and research from academia and software vendors. So we hope to, with this open data specification, to integrate it, all those different stakeholders to build a connected community. Okay. That's all from me. Thank you.
We do receive one question. Maybe I read the question.
Yeah, thank you very
or...
much for the presentation. There have been already 2 questions arisen in the chat. So first question is what the problem is you are like trying to solve. Is it more practical to help the stakeholders in a real system, or is it theoretical and you are doing the research in theory?
I feel maybe I answer this question. I feel that maybe the audience misunderstood our perspective. First of all, Peiheng is a leading engineer in a class 1 company, building large-scale routing, scheduling interface. We are not just simply try to promote academia-oriented researcher. He has many know-how. Second one here is overall multiple years of experience having a common data specification, particularly for routing specification, for scheduling specification, is much needed. We do see the gap between research and the practice, without the connection between all the wonderful talented students, researchers, building all the different type of algorithms, contributing back to industry. So we see the gap. We try to use our proposed method to at least to minimize the gap and then to reduce some confusion in between. Maybe Peiheng, you can try to just express your opinion.
This is not a single problem because we're building an ecosystem, and the intermodal planning involves different problems. So from the long-term capacity planning, network design, and the strategic planning involving the trip planning, so which involves the for railroad, so it involves blocking, train routing, and train scheduling. And then on top of that, we could encounter some of the operational planning problem, such like the mid and path plan. So because we have so many different problems, and previously we solved those problems individually. So we hope with this open standard data specification, we're building an integrated framework to embed all of them together, and eventually to provide a user an integrated and interactive user experience through a web application.
Yeah, and also I want to address, we are not selling a particular software product or even open source product. We think it's great for us to talk about the common specification first. So this still requires a community effort such as INFORMS RAS come to the same setting to discuss how do we represent node, link, different number of tracks precisely. I see we are building many different tools individually. It's a time for us to look at how to build the open specification. The corresponding network can be still accessed either in your private server, or you can make it accessible to the public. And I think the point here is open specification is a way for us to standardize many interesting applications along the way.
So there's a question on the web application. So everything here we developed is open, has the open access. So user can either retrieve the upload through the web application, and they can also trace back to the network. So there's no limitation on this one.
Okay. I see one question about how we can select different objectives in routing, minimal time, minimal distance. I think someone who has an optimization model, which could be beneficial by reading such node and link different path or column into C+ or any optimization solver, and then build the corresponding objective function more easily. And so the objective function is a user-defined. Here we are more talking about node link representation, path-based generation, and it's really just try to enhance the column pool if you have an enterprise application.
Okay, thank you for that. There's also been a direct message to me. If you can talk about the standardization of origin and destination data acquisition.
Peiheng, do you want to answer this question?
Can you repeat the question again?
Yeah, if there is any standardization of the origin and destination data acquisition.
Any standard, what? Sorry, I didn't get it.
Acquisition. So I think Maurice is talking about how to get the data. So at this stage, we have this OS into real. So most of the data set, if allow me to talk about here, is coming from OpenStreetMap, which also have the public sector track-based data. They are not accurate. They might not have all the necessary elements because they are the open data set. So for enterprise application, we still need to enrich this in terms of weight, in terms of specific blocking type. So at this stage, we are talking about open specification, and we think there's a many a rich set of attributes for the third party or for the in-house company to provide the information, and then later use this specification to share the data to outside.
Okay, thank you. I have another question about MATSIM. You mentioned it in the beginning, and it is interesting as we at the chair are also doing some research using MATSIM, but to my knowledge, it is mostly used for agent-based road transport traffic. So there was some development for rail related agent-based modeling, but I don't know if it was followed up. So do you have any knowledge if there is something coming?
Yeah, so I think we know this whole enterprise. We have MATSIM, we have Sumo, many leading examples. The challenge here is that we also have to deal with intermodal routing. We need to deal with time-dependent routing, energy-oriented routing. So the routing or the intermodal routing itself, or maybe multi-resolution routing itself, is a very complex problem. What we try to do here is to advocate the specification first, and then the different routing engines will be polished further, and then can be also included into MATSIM as a part of the column or part of the agent path into their engine. So what we try to advocate here is a common specification, common engine, and with all the customized feature, to the different current enterprise.
Okay, thank you. Are there any additional questions in the audience? Okay, doesn't I don't so Thank you so much for this really interesting presentation. Have a nice evening or lunch or whatever time zone you're at. And thank you so much on behalf of Nicola as well. You will, or we will provide the slides and this video recording so you can access it later, and we will distribute it to all of you. So thank you and see you at the next
Thank
webinar.
you for this. And I think standardization is way to go, as I always working with the Peiheng. The railway is based on standardization. Without all the standardization of time zone, clock, we could not synchronize that together. So we are looking forward working with our community to move this forward. Thank you so much for this opportunity.
Thank you. See you. Bye.